Welcome to another episode of Don't Panic Geocacher. My name is Arjen and I go by Waterfan5 on the geocaching.com website. Today I'm going to talk to you about coordinates. What are coordinates? What are coordinate systems? What are some of the popular coordinate systems? How to do some simple calculations that you might see in mystery caches with coordinates. Hopefully this will help you solve some more mystery caches, recognize different coordinate systems and help you solve some of those puzzles out there. But just to start, what is a coordinate, right? Just very simple. A coordinate is just a system or a mechanism or a technique to indicate a certain location. Typically on Earth, but of course anything can be a coordinate. Can be a coordinate of space, can be a coordinate of Mars, can be a coordinate of the Moon. But since we're talking here about geocaches and geocaching, it will typically be on Earth, right? But for a puzzle, it wouldn't be surprising to sometimes see something else that you have to find a coordinate in another system as an answer to a puzzle. But for most of this video, I'm going to just use Earth, keep it simple, and that's what we do. And you see on this map, it's simply a coordinate, it's nothing more to indicate a certain location. So here you see between Glasgow and Stuttgart, two locations, and they each have their own coordinate in a certain system that people agreed upon. Now, I'm going to talk about a wide variety of coordinate systems because there is many out there. But fortunately, primarily in most cases, we can focus on just a few. However, since we're talking puzzles, it is very popular to use some other systems as well. And I want you to be able to recognize some of these other systems. So I'm going to talk about some historic coordinate systems that might be used, especially when you try solving older mystery caches. And I'm also going to talk about some popular internet-based coordinate systems that are also popular because it might be able to create different styles of puzzles. And I'm going to show some of them to you and how to recognize them. And finally, I'm also talking to you about some regional specific coordinate systems. In certain countries or certain areas of the world, there might be coordinate systems that are just as popular as the main coordinate systems. And so if you travel or if you are located in some of those countries, it's important to know the regional variants that exist because a lot of puzzles may not tell you that they are using the regional variant, but you still need to know them. Otherwise, you may not recognize the numbers that you're getting and how to convert them to a useful coordinate for you. So let's take a look at some main coordinate systems. I'll start with the standard GPS, the WGS-84 system. This is the most commonly used system by geocaching, but also by standard GPS systems. And it has a set of components, typically the latitude and the longitude. In most cases, it will be it will have a letter with it that is either for north or south, N or S, or for longitude, west or an east symbol. It can be in front, it can be behind, it all means the same thing. Important is that there is both the longitude and the latitude has two pieces, the degrees and the minutes. So there is one space in between. We'll later on see systems that may have multiple spaces or have no spaces at all. And this kind of indicates which system we're dealing with is actually the number of separations that we have. So we have the letter indicating the direction, we have the number, which is the degrees, and then we have the minutes with the fraction of the minutes. Now all of these have specific ranges. So for a latitude, that is how far we go on a circle, how far we go up or how far we go down. And basically, since we're dealing with only a quarter of the circle, we only can go 90 up, north, or 90 down, south. Whether we are on the front of the back of the circle, we have to now occupy the entire circle. So therefore, this number goes from 0 to 180 and indicates the direction. Now, the direction is artificially set at Greenwich, London. That is basically 0. And we're just looking how far we go east or how far we go west. For the latitude, 0 is set to the equator. So much easier to remember there. As the numbers are for the degrees, the 90 and the 180, for the minutes, it's the same as the minutes of a clock and goes from 0 to 60 or from 0 to 59 with a fraction of that, where the fraction is typically rounded through 3 digits. So it's anywhere between 0 and 9999 if we take a 3-digit precision. So you see that here as the last part. But really this is just 41.352. It is just a fraction of the degree, if you think about it. So this is a very popular system. It's the most default system. And when you look at a puzzle, this is probably the first system that you assume it takes place. But it's not always the case, so we have to be able to distinguish it from other systems. And sometimes there is indicators that we're dealing with another system. For example, if the first numbers don't fit within the 90 and the 180, we might be dealing with another system. Or if the minutes go beyond 59, we know that we're not dealing with another system. Or if we need more than 15 or have a lot less than 15, we might be dealing with another system. Partials may be given, for example 40 and 74 might be given, and we may only have to solve the latter part. These are all things to take into account when solving a puzzle, and we're looking which coordinate system we're dealing with. Now if we go and look further, then for example this is again the Statue of Liberty, then we know that the minutes are a fraction of 60-minute parts of a degree within a degree, right? So that means that if it's, for example, written like this, it actually is the same as this, because 2.65 is the fraction, so 02.650 is the same number. So typically this one is 2 digits, this one is 3 digits long. But we can add extra zeros at the end, it would still stay the same number. And before the minutes, we can add zeros before, it still would say the same number, right? Because we're just looking at as the degrees and the minutes with their fraction. Now for calculations, often you may see in puzzle to say add this number to the north, or add this number to the longitude, add this number to the latitude. And what is then meant, if not further specified, is for example like this. Add 98 to the latitude means simple 352 plus 98 would mean 450. The same 671 minus 232 is 439. So if they simply do a calculation like this, then they mean to take it off the fraction part. There might be other ways to indicate it. They might also, for example, talk about projections, in which case you have to do a very different formula. But if they simply say add this number 2 or subtract this number 2, then you can assume it's taken it from the fractions of the minutes. With the standard system having to deal with minutes between 60 and 59, you can also see that there would be a system that doesn't take that into account. And that system is sometimes referred to as simply decimal degrees. So now the same coordinate, so this is the same Statue of Liberty, just has 2 digits, 2 numbers. So one number for the latitude, one number for the longitude. No letters involved, no minutes involved, no minutes degrees, and no spaces, right? Just 2 fractional numbers that you see here. Where, of course, the same rules for the degrees still apply. From 90, minus 90 to plus 90 for the latitude, and minus 180 to plus 180 for the longitude. So all of them have basically the degrees and then the fraction of the degrees as a symbol, as a single number. Note that these are fractions, so again 40.4 is the same as 40.4, and then add as many zeros as you want. Now for a calculation, it often means that you just have to add a whole number to it. So now if it says add 1.2, and this is the coordinate system that they're working with, it now means that you have to add 1.2 degree. And the same, if they say subtract 0.5, it means subtract. Now here it's where it comes tricky. In the other one you saw subtract, and I was just subtracting from the whole number because it was a positive number, because west and east or north and south avoided having to use negative numbers. But here, if it's a subtract, the number will actually become more negative. So subtracting 0.5 is actually minus 0.54 and not minus 73.5. So it's important to take into account that when you're dealing with decimal degrees, that the positive and negative now impact how you work with the number. And here you see the outcome of the calculation. Now this is a very popular system because it's also easy to calculate with, and you can see it in quite a number of puzzles. You will see this number because it's now a single number that can indicate a coordinate part like the latitude or the longitude. No spaces, no letters, nothing else to indicate. Of course, here, for example, you see that the third character now is a 6. With the standard DWS system that I just talked about before, there was no such thing as 60 minutes. So if you see, for example, a number like this, 40689920, we know that it can't be in minutes because there is no such thing as 68 minutes. So this has to be a different system. And for example, right now, this could be the decimal degree system. So important to understand this system and how it works. What is also important is that you know how to convert to and from this system. So let's take a look at some examples here. So we had the Statue of Liberty, and this was the decimal degree number. And now let's convert to the WGS-84 system. So what you do is basically north means positive, east also means positive, south and west are the negative numbers. So what you have to do is have to put those letters back into place. If it's a positive number, for the latitude, add an N, otherwise negative, add an S, and the same for the longitude. Remove the minus and replace it with a W, or if it's a positive number, add an E. Now you take the whole degrees and use that as a value, so we no longer deal with negative numbers, and the fraction you multiply by 60, and you round it to 3 digits. So if we take this and we multiply by 60, we get 41,352, and the same, we take the fraction here, we multiply by 60 and we get 2.6, and we add that leading 0. As I talked about, the standard typically does 2 digits and then 3 digits for the minutes part as the precision. So that means that if we want to convert this to the WGS system, we get 41.352, 74,02671. That is the same coordinate again that we saw on the previous slide. But you can do this with a simple calculator. You can just do this conversion, and it's good to know how to do this because for field puzzles or for other things you may have to do this in the field, and it's good to understand how to convert from one to the other. Same if you want to do in reverse, of course you now do it in the opposite direction, and instead of multiplying, you're now dividing it. So we have the fraction system of the minutes, we divide it by 60, and now that becomes the fraction of our total again. So we had 41,352 divided by 60, 0.6824. We add that again to the initial 40 that we had for the degrees, and we get 40 and then the fraction. Same for the next one, we had 0.2671. We divide it by 60, and that becomes our fraction to the degrees. And of course, because it was a west, we had to add a negative to it. And that's how you convert into both directions. Next thing, I'll talk about some historic coordinate systems. Why are these important? Well, very simple. Sometimes you encounter them in puzzles. All these historic systems have in mind that they're typically very paper-oriented. They were designed to make calculations on paper easier. And so the system that you will see, they have some kind of correlation to more older systems. And that's how they're designed to make it easy to do simple calculations in a certain area. The first one is the so-called Universal Transverse Mercator system. And this one divided the Earth into these different squares, as you can see here. And these squares were simply just made by agreement, as you can see here, where each of them had a specific number of the square. So for example, if you did 18T, then basically this is the T and 18 would be right here. So again, the Statue of Liberty would be in the 18T, and then basically it's what they call is the northing and the easting of it, which is then the number within that. And that number can be in meters or feet or anything else, but the default is in meters unless otherwise specified. So this is just a simple way to indicate where, for example, now something is. So again, this is where the location of the Statue of Liberty is. Talks about which square am I in, and then within that square, what is my kind of location. So each of the squares are roughly the same size by like 6 degrees, so it gives you a certain number of squares. And then within that, they could just use within meters. They could just say go this many meters north, go this many meters east or west, because they had these simple numbers to work with. Made it very easy to calculate. The military actually used a variant of that, the so-called MGRS system. The military's variant that used a very similar format, only so you see some very similar recognition of the number, only they use slightly more letters at the beginning, but after that you see the same meter system that is being used at the end. So especially if you go to old puzzles, you can see that they're using this format, and they may ask you to do calculations with it, simply in meters or miles or feet, whatever they tell you to do and whatever the system is that they give you the number with. The default being, like I said, often meters. I highly recommend using tools to convert, but if you have to do specific calculations, they may expect you to do the calculations in that system and then do the conversion back to a GPS system or to a standard other coordinate system, simply because that's how they made the puzzle and that's the precision that is needed. So wouldn't recommend to calculate this by hand. Only the math by hand is easy. Simply say, okay, north more. Then it's simply add 100, it will become 834 instead of 734. And same if you subtract 200, go 200 south, then it would become 534 south. It's very easy to calculate, you don't have to do anything else. So in a way, it's similar like the decimal degree, that it's simple math allows you to do simple locations, and as the world was divided in these different squares, the curvature of the Earth was not so relevant. Another historic system is the so-called Maidenhead system. And the Maidenhead system comes from the amateur radio operators world. And this one used alternating pairs of letters and numbers. So you see here 2 letters, 2 numbers, 2 letters, 2 numbers, 2 letters, 2 numbers. And each pair that you add adds more precision. So Fn already indicates a location. So here we see Fn is actually Northeast America. If I do Fn20, it gives me a square within America, so roughly around the New York area. Now if I add XQ, I get more precision, and so on. The more pairs I use, I basically each time divide my square into smaller squares, and I alternate numbers and letters, adding more precision each time. And so the Statue of Liberty would now be at this location, but if I remove precision, then still might be the Statue of Liberty in that square, but the square would just be getting bigger, bigger, and bigger. The typical names they give them is field, square, subsquare, and extended square as the locations, but I've seen other terms being used as well. So it's quite easy to recognize because they use those pairs of letters, so where you see the letters and numbers, and so if you see something like that, and especially when it has like this length, so you see here 4, 8, 12, so if you see something like 10 or 12, it might very well be an easy Maidenhead coordinate that they're giving you with. Often there might be hints on the puzzle because it's not the first thing people think about. It's something like references to the radio operators to indicate this coordinate system as well. So this is just another example of a historic coordinate system. Of course, there's also many regional coordinate systems out there which are historic. In all scenarios, I would recommend using tools to conversion and don't worry about the conversion, doing the conversions yourself. The internet has introduced a variety of new coordinate systems. These coordinate systems are typically proprietary to a specific website, but other websites may have the ability to convert from and to that coordinate system as well. So I'll explain a few of them that I have seen in a few puzzles and you may encounter as well. The first one is the so-called Google Plus code. This was introduced by Google to indicate a location on the world. And in a way, it very similar works to the Maidenhead system. It divides the world in squares, and the more characters you provide, the more precision you indicate. Unlike Maidenhead, it allows you to skip the first part as long as you provide a city or a region. So let's take a look at an example of that. Here we see the same coordinate for the Statue of Liberty. Now, unlike other coordinate systems that we've seen, there's no division of longitude and latitude, but it's simply a single system, similar again like the Maidenhead, where it refines more and more the precision of your location. If we remove the first 4 characters, we can replace that with a city name, making the code shorter, and now we can just say New York, for example. But if you don't include New York, this will be a relative location to wherever you are on Google Maps. So you can try that by typing in the location in Google Maps without New York, and unless you live in New York, it will show this location in your area, which can be very different. So with puzzles, it's always important to add the city or add something behind it if you received a shorter code and didn't receive the first 4 characters. Now, very recognizable with the Google Plus codes is the plus symbol in it. And this is just a divider in the code between the first characters and the final characters. But as we define more characters, we define more precision, as I earlier indicated. And we can see that here with an example. You see in here, it's the +5 and it is the statue plus liberty part of it, the statue, but we can see on the map, it's a pretty significant area. Of course, if we leave the M5 out, then now it is a much bigger area of Liberty Island. Still including the Statue of Liberty, because it is a sub-square of it. To be exact, the M5 sub-square. But it's a pretty significant area. But if we wanted more precision, then we would need more characters. And you see that here, and it might be hard to see, but here there is a single red dot. Probably not more than like an inch or so on the map. Or at least less than a square foot. And so you see by adding more characters, we can get more precision of our location. So this is important with puzzles, that you provide the right location, but also either include the 4 characters or somehow the user needs to add the city name to it to get to the correct coordinate. Now, this is a proprietary system, so Google has made this system and they do all the conversion. But other websites like Cache-Sleuths and Geocaching Toolbox also have tools available to convert from and to Google Plus codes. Another popular new system is the so-called What3Words website. With What3Words, as the name already indicates, every location on Earth is identified by 3 unique words. So for example, encounter wooden stable represents that same GPS location that I've been using before in other formats. So it's always 3 words, and the 3 words are randomly assigned, meaning that if you only have 1 or 2 words, it doesn't identify an area. And this makes it ideal for geocaching puzzles, because you would have to know all 3 words to know the exact location, knowing only partial words, knowing only part of the word. So for example, encounter wood stable is a location, but somewhere completely different and in a different area. The website supports multiple languages, so you can get the location in any language and it will be different words. So it's not translated words, they will just be different words just in that language, French, German, whatever you selected as a language. So here you see a screenshot with some locations marked. So this is the one that is Encounter Wooden Stable. And you see locations nearby have used very different words. And also, if you change your language, you can get, for example, here is a Dutch variant of a location. And so you can play with different languages and even have just 3 words in other languages. I've seen puzzles where they have Chinese words or French words used for the location. So this is something to watch out for if you see in a puzzle and you're clearly given 3 words, that it might actually identify a location using the What 3 Words website. So yeah, something to watch out for. You can use the what3words.com website. You can also use Cache Sleuth or Geocaching Toolbox to do the conversion. They have integrations of the What3Words website and can do the conversion for you as well. So they are integrating to it. But yeah, very popular system used in many geocaching puzzles. The last type of coordinate systems are so-called regional coordinate systems. These are typically historical coordinate systems that were used in a specific area of the world, typically a specific country or set of countries. So these coordinates will typically don't work worldwide and only work specifically and may use specific things that only make sense locally. I'll give a couple of examples of this, but won't go into much detail. But it's certainly important to take these into account, especially when solving caches internationally, that it may not be a coordinate system you're familiar with, but they might be using a regional popular system. So the first one is the so-called state plane system. The state plane system looks a little bit like this. So for the Statue of Liberty, we have again a region and then an offset that you see in meters with an eastern and a northern. So in that way, it is very similar like the UTM system that we saw before. So it divides the US in specific regions, and within that region, you can now identify the offset within that region using the northern and the easting. So yeah, pretty unique in the way it's formatted. So you have these 3 sets of numbers. It's not used too often. Again, it's more a historical one, but there is specific websites that can do the conversion for you in case you encounter one of those coordinate systems. The UK also has its own, and as I mentioned, a lot of these coordinate systems only work with regional coordinates. So you see here that the UK is divided again in different squares, and now they have the offset, similar like the other one did, the state plane system within that grid, but now within the UK. And so, for example, the Big Ben in London has the following coordinate. So TQ will match the square, and then it's the offset within that square. So again, pretty straightforward to recognize, and you may find when you solve a cache coordinate, for example in the UK, that you have to deal with the so-called OS&D National Grid System as a coordinate system. Fortunately, there's websites to help you convert. For example, Cache Sleuth can convert from and to this system, but there is other websites as well. The last example that I want to give you is for the Netherlands, but really most countries have their own system, but may not be very popular for geocaching. The Netherlands is probably one of the exceptions where the so-called Rijksdriehoek is very popular to use in puzzles and may often be the default coordinate system that is being used. So very similar. In this case, there's just one square. It's a smaller country where you just talk about the easting and the northing. So 2 digit numbers, and you can see why this would be popular, because it's only 13 numbers that you would have to encode, and they're just very easy to work with in a puzzle. Also here there's a variety of tools. Geocaching Toolbox has tools to convert it, but there's again other websites as well that can help you with that. So here I use the example of the Amsterdam Central Station, and it would have the following coordinate. So something to watch out for, especially when solving international or when a puzzle has a specific theme that is related to a specific area, that it might use a regional coordinate system. The third primary system is the degrees, minutes, and seconds. So now every longitude and latitude has three components: a degrees, a minutes, and a seconds, all separated by spaces or maybe by the minute and second symbols as you see right here. Again, the N and W can be before or after, that doesn't really matter, but the degree ranges are the same. However, now the minute ranges are just a number, so meaning any number between 0 and 59. We no longer do the fractions. The fractions are now written down as seconds or fractions of a second. So that means that the third number that is here, so we have 40 degrees, 41 minutes, and 21.12 seconds. So now means that we have 3 digits to work with for the latitude and 3 to work for the longitude. But the ranges stay the same, except now with the seconds, similar like the clock, goes from 0 to 59. So now it may ask you to do a calculation, but they have to tell you what to do. They have to tell you add so many minutes, add so many seconds. And so this might be slightly trickier because now you have to each time take into account that this is kind of like stops at 60, right? Or if it goes below 0, that the next one starts with 60. So if, for example, if it says add 1.4 to the latitude, it means that 1 minute 40 seconds. We now have to say, okay, to the minutes, that is easy because it would become 42. But as we're adding 40 seconds, we would get 61 seconds. So we'll have to add another minute. And now basically it becomes 43, 1 second and 1.112 second. So we have to take that 60 into account every time we do a calculation. With the number, as we subtract from the absolute number, so we don't care that it's about west or east. In this case, we subtract and we do 3 minutes and 50 seconds. So in this case, it would say from the number we go down. Now note here that if we subtract, we only have 2. So we actually have to subtract from the degrees. And now again, the minutes start at 60 again. So that would go from 60, it would go down. And the same for the seconds, it starts at 60. So hence you get 73, 58, 50.26. Because if we did 50 seconds, we have 10 short, so we have to borrow 10, etc., etc. Standard math, but basically into 60s. So this is a common system, especially if you start talking about, for example, sea navigation or older navigation. It might be a system that is used, and often it's indicated as degrees, minutes, and seconds when you see that. So it has these 3 segments. Again, also important here is to understand how to convert between one and the other. So it gets slightly trickier because we have to do 2 conversions, one for the seconds and one for the minutes. So for the seconds, we basically say, well, we divide this seconds, which is this part. And then for the minutes, we also have to convert, which is, of course, for example, this part. And now we get the combination of the 2. So we see 40, and then we have the 41. We can just borrow that straight across, right, as you see here. And then for the seconds, we simply have to divide it by 60, because this was a number that was from 0 to 60. And so now we see for to convert it to WGS-84, we see it like this. If we want to convert it to the decimal system, we have to do one more step and again divide this number by 60 to go to the decimal system. So there is a logical path to get from one to the other by each time doing the division, or if you want to go to the reverse system, by multiplying. So you see here the 355 The remainder, we multiply that by 60, but then have to divide it by 1,000 to get the seconds. And so therefore you get 21.12 seconds. Same here, 60 now divided by 1,000. Initially, we already divided by 1,000 by simply here multiplying by 1,000, right? So that is where the reverse one comes into play. We multiplied by 1,000 here. So that's how you convert between the two systems when you deal with decimal minutes to the standard DWS-84 systems. So this is really, I would say, must-have information that you know how to use. You need to understand the three different systems that you can recognize. They have 2 pieces, 1 piece, or 3 pieces. The default one, where the ranges are, so where they stop, right? Which one goes to 60, which one goes to 90, which one goes to 180, which one uses plus and minus systems, and kind of how to recognize each 3 of them and how to convert to them with a calculator, or in worst case, pen and paper, right? Because for field puzzles or other scenarios, you may run into this. And so it's for everybody essential to understand how these systems work. So that was a lot of information. So let me give you a little bit of a summary. So we had all the different coordinate systems, where really these are the 3 main systems, right? The standard DGS with the latitude and the longitude, where this has 2 segments, the degrees and the minutes and the fraction of the minutes. Then we have the decimal system, where just 1 number for the latitude and 1 number for the longitude. And then we have degrees, minutes, seconds, which kind of is a variation to the first one, but instead of having degree fractions, we now talk about seconds. Talk a little bit about some of the historical systems that are out there. But of course, really every region may have its own historical system out there, and it's important to understand when solving puzzles. And finally, some of the internet design systems that may be out there that have gained in popularity for puzzles. And it's important to recognize them even more so than knowing how to convert them. So for the main ones that we just talked about, I would recommend that you know how to do the calculations. So that was the plus or the multiply by 60, divide by 60. And certainly for the other ones, I would recommend that you make yourself familiar with the format of them, so when you see them, that you know and recognize them as a coordinate system. Furthermore, never forget what 3 words in Google Plus code. If you see a plus in something, it might be a plus code. If you see 3 words being highlighted, it might be a what 3 word system. Finally, this was only a few of them. There's many more. I name a few here, and these are all variants of coordinate systems. Even a system like a reverse where I go is again just a coordinate system. In that case, a very randomized coordinate system for the utilization that it uses. So you may encounter those, and if you see some of these words, it may indeed encounter to another coordinate system. But you may also start looking these up, see what they look like, and gives you more coordinate systems to recognize. I would recommend, other than for the main 3 ones, which I think everybody should know how to calculate between those, for other ones, just use tools, and I will give a demonstration of some of the tools that are available that you can utilize. The final lesson that I want to talk about here before I go into the websites and demonstration is about the precision of these. We already saw with, for example, with Maidenhead and Google Plus code that the precision is not hard to define. Even with what 3 words, or when you convert from between different coordinate systems, you may lose some of the precision. Therefore, I would often recommend that as a geochecker, you use one that allows error margin. So for example, a 10 feet or 30 feet radius, because the conversion between coordinates, it may not be as exact, and so a single coordinate system may not convert well to the standard coordinate system used by geocheckers. And so a margin will help prevent that somebody has the right solution, just is maybe slightly off by 1 number. So these checkers, like a Certitude or a GeoCheck, can help you with solving that problem. Now, I mentioned some of the websites. I will show two of them. Cache Sleuth has a great website. I'll definitely demonstrate that. Talked about the what three words, specifically for what three words. I will also show Coordinate Converter because it converts to many different systems. And then we saw some of the other ones that I mentioned in this presentation that can be used for the different formats that were specified. So the first one I want to show is the Coordinate Converter website. Well, as the name says, it's designed for coordinate conversion. And I really like this website because of the amount of coordinates that it can convert. So it has an integration with Google Maps, and I will show you that in a second. It will of course have a map, so it can show the location that it is, and then it will automatically convert to the three main ones, the degree, minutes, seconds. It will do some of the other coordinate systems that I talked about, like UTM, MGRS, and it also has some of the newer ones, like what three words and the plus code. In addition, it also has some support for some of the regional ones. Not all the ones that I talked about, but definitely it has some other ones that I didn't talk about for specific regions. So a wide variety, and so for example, if I type in here Statue of Liberty, because of the integration where it can show that, it will then go to the coordinate, and I now get the coordinate of their interpretation of Statue of Liberty, where that is located in the different formats, as you can see here. Only criticism I would have is that there is not an easy copy and paste for some of the formats. So you see, like right here, there's not an easy way to get that copied across, but it does do the conversion that you have right there. So it has the nice integration with what three words as well. So we see for this specific coordinate, it's party energy reverse in English, but if you want it in a different language, you can get that as well. So I can see, and then it will update and it will show what that coordinate would be in another language, right? The same location. It also gives the Google Plus code location, as you can see here. So that is also nice, but it doesn't give it necessarily the highest precision. It could add a couple more coordinates right here, but it's enough to get you in the right area for this location. So yeah, so a lot of cool features right here, and so very useful to do a quick conversion. You do have to know which coordinate system it is, so you enter it in the right field. So if you don't recognize right away, you will have to enter it in the right location. But the good thing is that it has this separation. It put everything in separate input fields. So that means that it helps you structure the code as well to make sure you enter it in the right format. Now, the same way that it can convert, it also can convert back. So of course you can enter it in any of these formats. So you don't have to use what I just did. But for example, if I change one of the formats and I press the calculate, it will update the map, but it will also update all the other formats as I've specified. And so if I go back with what three words, it will now show what three words is location. So it's an easy way to go back and forth between the different ones. And if I type in another different what three words right here, and here you see, for example, how similar words can bring very different locations, because now I'm no longer in New York, I'm somewhere completely different. Let's see where I am. Looks like in Iowa. I'm somewhere in Iowa right here. So you can see how this works and how quickly you can switch between the different coordinate systems and experiment and see what they look like in the other formats. The other one I use is Cache Sleuth. Already explained this website in other videos, but they have a good coordinate conversion tool as well. If you go to Map Tools, then Coordinate Conversion, it will show here the place where you can enter the coordinates, and then it will automatically convert to a wide range of different systems. So you see again the three main ones: the decimal minutes, decimal degrees, minutes, seconds, the what three words, MGRS, UTM, plus code. You see some of the ones that I didn't go into, GeoHas and GeoHex, they're also calculated. But also some of the regional ones, in this case the OSGB, is also displayed right here. So yeah, this is a nice, what I really like about this one is that it will just recognize the coordinates. So if you format it correctly, so for example, I can enter what three words in here, and it will automatically convert it to a coordinate. And this one does allow you to easily copy it, so that's very nice. But in the same ease of use, I can just say, okay, I put in a decimal coordinate, and I will slightly adjust it so that we can see the screen change. So here it now converts it, and we see it in the different formats. We now see it being displayed 41, 41, but also the what three words has been updated. Note this one doesn't have the language feature, so you can't change the language in here, but that's not often needed. What is nice that it gives the antipode, and the antipode is basically the same coordinate at the other side of the world. So for north, that means that the plus becomes a minus, and for the latitude, for the latitude, it means plus becomes minus, and for the longitude, it means it's 180 minus the number. So you see here 180 minus the 74 is 105. And of course, the opposite direction, so in easting in this case. So that is another nice feature that it has right here. So yeah, it has the map here at the bottom, so you can also view where the coordinate is. It doesn't display it at the same time, so you have to scroll a little bit. But yeah, it does have the nice automatic detection here. So those are the two that I would say I would use the most when on when behind a laptop or a computer, right? Note that when you're in the field, it might be useful to have just tools installed that can do it. Some of your geocaching apps that you may use, like CGeo and Cachely, have conversion ability in there to convert coordinates. You can also install specific tools like GC Wizard or GC Tools on your system, and they will allow you to convert between different systems as well. This can be useful when you're in the field, don't have access to a laptop or a computer, and you need to convert between the different systems. It's often easier than doing it by paper. So these tools can help you, and so they're for the phone. So with that, that was the end of this presentation. Hope you enjoyed it. As always, if you're not subscribed, please subscribe. A lot more topics to cover, a lot more tips to give about how to solve puzzles. If you have feedback, please leave a comment. You can also reach me by waterfed5 on the geocaching.com website, or by geocaching.waterfed5@gmail.com, and you can shoot me an email. With that, thank you very much for your time. I hope you appreciated it and hope you enjoyed it and hope you learned something, so that when you see a puzzle that you have to panic less and maybe solve more. Thank you.